Hey guys, I got a few messages from some students about having trouble with this balancing chemical equations assignment, so I wanted to do a quick tutorial of it while I am out this week. So, first of all, you need to go into the Schoology assignment for today and open up the balancing equations assignment. When you open it, it should look like this. It's in the new Schoology folder that is labeled Mastering Balancing Equations for this week. Once you get here, you'll find this, and here's where we're starting. So once you open it up, if you read the directions, first of all, it says everything you need to know in the instructions about where to find it and what to do and where to click and all the appropriate links. Go ahead and pull that up just so I got it for you guys here. All right, so down here at the bottom, mastering chemical equations, and I'll show you the instructions. So follow the instructions to go to the Gizmo. This is also a link. There's another link, and there's a third link in the title. So if you can't get to Gizmos, I don't know what to tell you, man. So they get there, follow the instructions, fill in the orange boxes. If you can't get in, reset your password to get in. And if you've never made a code before, there's our class code. You can make a new account if you need to. So again, this is what the assignment should look like, and when you get here, this is what you should see. When you get to your Gizmo page, you want to open up the balancing Gizmo's equations. Should look like this when you get there. Oops, wrong button. All right, so the beginning part is pretty straightforward. Again, you're seeing this H2O2 equals water equation again. We've used this a lot, and the only reason we're doing this is because it's very simple and straightforward and easy to see. So you should set up the equation to look like this on the right hand side, just like in the picture. Okay, so it says follow the instructions, go through simulation, respond to the questions in the prompts, the orange boxes. In a chemical equation, the reactants interact to form products. This process is summarized by a chemical equation. In the balancing equations gizmo, look for floating molecules below in the initial reaction. H2 plus O2 is H2O. And my screen is taking a minute. So when it loads up, here you are. This is what it should look like. I'm gonna go full screen, a bit easier to see. All right, so it's a synthesis reaction. You have H2 with the 1, you have O2 and H2O. You can see the molecules floating around in there. And so that should help you answer the question, how many hydrogen molecules do you see? Or how many atoms are there in a hydrogen molecule? So if you look at the hydrogen, there's 1 atom, 2 atoms. All right, how many are in oxygen? Also 2. So again, the majority of this assignment is literally reading, following instructions, and using your eyeballs. How many hydrogen and oxygen atoms are there in an H2O water molecule? All right, so 1 oxygen and 2 hydrogen makes 3. In general, what does a subscript, such as the 2, tell us about the molecule? All right, and like we've been over this. If you don't know this one, look at your notes, and there is literally this answer in there. What does it tell you? It tells you the number of atoms that come before it. That just tells us the number of atoms there are in that molecule that come before that subscript. So like the 2 comes a 2, and the O2, talking about the O in front of it. So a chemical equation is balanced when let me try again. A chemical equation is balanced if the number of each atom on the left side is equal to the number of each type on the right. Is this one balanced? So again, we've been talking about this and we've done this in several warm-ups last week. Is this balanced? Do you see the same number of hydrogens on the left side and the right side? Yes. You see the same number of oxygens. Then look at the red dots. No. So it should be a clear indicator that you got something fishy going on here. And again, that's looking up here, there, and here. All right, you should see that they're not the same. So that should be a good indicator that you got something going on that you need to fix. All right, so down to activity A. Again, the most important thing you can do is read the darn instructions. So here they are. Check that the synthesis reaction is selected and that all the coefficients are set to 1. The coefficients are the numbers in the boxes. So again, all right, we got synthesis here. 1, 1, and 1. I'm ready to go. I'm following instructions. All right, so in this equation is unbalanced because there are 2 oxygen atoms on the reactant side and 1 on the product side. So remember how I say use the test to take the test or use the quiz to take the quiz? You just got the answer to this one right here if you read right there. So again, reading is the key to these assignments. I know they're not they're no replacement for doing actual stuff in class, but while I'm out, they work in a pinch. So to balance the equation, you cannot change the structure of the molecules, but you can change the number of molecules that there are. So how are chemical equations balanced is question 1. Again, turn on show histograms. That's instructions. So go to here, show histograms. All right. The equation is balanced when there are equal numbers of each type of atom represented on each side of the equation. All right, so it says use the up and down arrows to adjust the hydrogen, oxygen, and water molecules until they're balanced. When you're done, turn on show summary to check your answer. So in here, I'm going to adjust these numbers until down here at the bottom, it's all equal. So like what I'm looking for is this right here, all these to be equal. If they are not equal, then we are not done. So if I click show numerical values, that can help too, because then it shows me how many I have. So right here I have the correct number of hydrogens in 4, right there, right there, but it mismatched in oxygens. So I need more oxygens on the after side of the equation. All right, and what you can do is move these around until now they're equal. All right, so let's go back and look at that again. So if I click show summary, it tells me right here it's not balanced. It tells me I'm not good to go. So 4 atoms and 4 before, and then 4 and 2 after. Keep changing these around until it says it's balanced. So now that it is balanced, I can put these coefficients in the boxes. So I can put a 2, 1, 2. This is basically how you're going to do every one. So when you see these ones down here, every one is going to be the exact same way, just like that. From what I saw before online, you guys are pretty good at balancing equations from that last assignment we did where we were practicing balancing equations and we circled and squared the coefficients and the subscripts. So I think you guys should be pretty good at this. So this is just meant to help you see what this looks like with like a cartoon. So all those reactions here, all right, use the choose reaction drop down menu to see other equations and balance them. So that's how you get to all these equations here, is by simply choosing them from the drop down menu. So if I click here and I go to single replacement, look, I have the AlHCl, AlC3, or Al3. So if I go down here, look, that's this reaction right here. It's the first one. So then you can go through and change these around. and see if they're balanced. Again, if you have the show summary buttons clicked, it helps you see. And then also down at the bottom, you can see graphs of how much of each atom you have. And you're going to have to go back and forth and change these around until you figure out how many of each one you have and make sure that they're all equal. So a good way to do this is go through and kind of just look on each side of the equation. So before I have 2 aluminums, and after I only have 1. All right, so if I drop this down, they'll be equal. All right, before and after I have 3 chlorines, before and after I don't have equal hydrogens down here. Okay, so I have to play with the hydrogens. All right, so if I have 2 on this side and 3 on this side, which I did in order to make the chlorines be equal, you're going to have to find another way to go. So you're going to have to keep going back and forth until you get them right. So aluminum's going to stay 1. All right, so that means I need to find hydrogen first. I need to balance hydrogen first. And if you remember, well, no, we didn't do that one. So let's start here. So hydrogen and hydrogen here. All right, so then I can keep increasing until I have equal amounts of hydrogen. So you see how I just kept playing with the numbers until I found that the numbers of hydrogen are equal now. All right, so now the number of hydrogens are equal, I can work backwards. So I have 6 hydrogens and 6 chlorines. And I can get 6 chlorines out of this AlCl3 by having 2 groups of this. So now I just need to go back and do one more, and I'm all set. So again, this is going to take some trial and error, and I told you guys that you need to take your brain out of chemistry mode and put it just in that game mode where you just try to solve. Okay. So now I can go back here, 2, 6, 2, 3, and that's what I put in the boxes. Here, 2, 6, 2, 3. And that's what I'm looking for. Okay, and then you can go and select another equation like decomposition and start the process over. I do want to show you one thing, that if you ever come across something like this and you're putting numbers in that look like this, like you say it says let's say 2, 4, and 2. Oops, wrong button. All right, now this is not the correct answer, but I do want to show you this. If each one is divisible by all the other ones, so if each coefficient is divisible by all the other ones, like you would in math class, like in math class you wouldn't leave a fraction of 2 over 4. All right, that'd be wrong because it could be 1/2. In this situation, each coefficient could be divided by 2 evenly. So you can go ahead and do that to simplify the reaction. So if I did that, it would be just a 1. 4 divided by 2 is 2. And 2 divided by 2 would be 1. And then this would also be the same answer as before. Okay. Now again, these are not correct, but I just want to show you that if you have common multiples among all of them, then you can reduce the coefficients. Okay. Now moving on to these ones down here. All right, these ones, like I said, are not in the Gizmo. So this is just more practice. And I told you, like with the Sudokus, you just got to practice. And that's the most important part. So if my computer Stops running so slow and goes down. I'll show you how to do one of these. All right, so I want you to list your products and reactants, and I want you to put the coefficients in. Now, if you're used to putting in 1 in the coefficients, that's fine, but I don't want you to eventually break that habit because you don't need a 1 in a coefficient if it stays a 1. You can just leave it blank. So what you start here is you look on the reactant side, and that's why I split it up for you. By clicking here, I see Na and I see Cl2. So I'm going to put Na and Cl. A quick trick you can do here is copy and paste them over to the reactants because the law of conservation says that whatever you start the reaction with, you're going to finish the reaction with too. Because if you can't just make a different element out of a reaction that was not there to begin with. Okay, so I'm going to do that and just clean this up a little bit. All right, so then that will make it easier to line up your coefficients. So I have currently on this side, I have 1 Na and I have 2 Cls because of this subscript here. In the reactant, I'm sorry, the product side, I have 1 Na and 1 Cl. So the NAs are equal, but the CLs are not. So you always start on the lower side and ask yourself, can I multiply that number so that it equals that number? In this situation, the answer is obviously yes. So you ask yourself, what do I multiply that by? So 1 times blank is 2, and that answer is 2. So I'm going to change the coefficient where that element appears to 2. Now, since these are bonded together, if you change one, you have to change both. So I'm going to put a 2 here. That means I multiply everything down here by 2. So Na and Cl, 2 times 1 is 2, and 2 times 1 is 2. I do want to point out that all this is a way to count. This whole products and reactants business here, this T-chart, it's nothing special. It's just a way to keep you organized and keep track of your numbers. It's not like a magical chemistry anything. So it's just a way to keep you organized. All right. So now that chlorines are balanced, I can come back over here and I can fix the sodiums. So Na. So I ask myself again, can I multiply this to equal this? The answer is yes. 2 times 1 again makes that correct. So 2, and then that only will change the count of my sodiums, my Na, to 2. So I'm going to change this to 2. And now everything is equal and I am done. So a couple things. You can leave the reaction like this. If you want to clean it up, you can do that. If you put a 1 in for now, I'm going to let that slide, but technically that's not correct. So down the line, I'm going to start marking that wrong. Okay, so that's how you do 1. Okay, let's go down and I'll do one more. Let's see. All right, this number 6 looks ugly, so I'll try that one out. All right, so I list out everything I see. So I see an I symbol, I see an Na symbol, I see an S symbol, and I see an O symbol. Oops. Now again, don't worry about the subscripts at first. List every element you see, I and A, S and O, and then where the arrow goes, that's when you stop. So I'm going to highlight this, copy paste. And again, you don't have to do that, but it helps all your counts line up so they're easy to see where the mismatch is and if they're equal or not. All right, so next I'm going to say I have how many I's. Look up here, I'm going to check out the subscript. It tells me that there's 2. There's no coefficient, so I'm going to leave that alone. All right, this subscript here is 2 for sodium. The subscript here is also 2 for sulfur. and the subscript is 3 for oxygen. Switch sides. For Na is the first one I see. You could either go by that or you could go by how you have them listed. So for simplicity's sake, I'm going to go by how I have them listed. Again, you don't have to do it this way. As long as you get the counts for everything, you're good. So I have one Na, I'm sorry, one I. I also have one Na because there's no subscript and no coefficient for these two. For S, I have a 4. And for O, I have a 6. All right, so you can choose one thing to start with. It doesn't really matter. Now, before I go on, I want to point out something I made a mistake on that I want you to see. This is that I have Na in 2 locations. So I have an Na here and an Na here. That's a total of 3. So I'm going to change this to 3. All right, you got to be careful when you do that. See, as I showed you, sometimes I can fall for it too, but as long as you catch it before you move on, you're good to go. All right, so good catch. All right, so normally we're not going to start at the NAs because they're going to appear twice. So we're going to try to balance other things first and go from there. All right, so let's see here. Here's what I'm looking at here. I see a little pattern. All right, I see there's a S2 over here and a 4 over there. That's an easy multiplier. And 3 and 6 is also an easy multiplier. Furthermore, it's nice that as long as I double this, I'll get 4. And same with 3, I'll get 6. So that means I have to double where I find those things on the reactant side. So sulfur I want to make into 4. So 2 times 2 makes 4. Sulfur appears up here, and it's all bonded together with this stuff. So I'm going to put a 2 in front as the coefficient, and that tells me 2 times this, 2 times this, and 2 times this. So I have to multiply my sodium on this side by 2, so 2 times 2 is 4. Sulfur is 2 times 2 is 4 as well. And then 2 groups of 3 would make 6. All right, so by doing that, I've made 2 out of the 4 symbols equal. S is equal to S, O is equal to O. All right, so now I can look on this other side. So I need to make NAs 4, and I got 3 over there. So I need to add one more. All right, so I can add that here. I don't want to touch this one because the S and the O are already balanced. Another indicator that that's also the right move is that you can easily start on the lower end here of iodine, or I, and easily make it into 2. So 1 times 2 makes 2. So I'm going to have to multiply this one by 2. All right, and again, all the stuff below is a way for you to keep track of your numbers. So you don't necessarily multiply 2 times 3. I've seen that mistake a lot. You multiply 2 times 1 makes 2 here, plus 2 more over here makes 4. Again, we're looking for the total number of Na symbols on the product side of the equation. And when I put a 2 here, not only does that fix this, so 2 times 1 makes 2, that's equal. 2 times 1 makes 2 sodium here, and then plus 2 more over there makes 4. And would you look at that? You fixed it. A lot of times you don't need to attack the ugliest one first. Sometimes they work themselves out. So start with the simplest thing to do first, or look for a pattern that might be the easy fix for it. This is the end of the equation, and you are correct with this. So again, I can delete these yellow boxes to prove that I know that I don't need to touch those numbers. So again, practice, 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 practice. Okay, I will take off more points for students that don't attempt or don't try or don't put any effort in If they leave this blank, it's going to be more off than if you just make a few mistakes here and there. Because again, from this you learn by trying over and over and over again. All right. So if you need help, reach out to me. If I need to make another video, that's cool. But let me know if you need help, and I'll give you guys another day to do this because I know I wasn't there. So I'll give you guys an extension on this and try to work on it again. All right. I'll talk to you guys later. Hopefully this helps.